Hello, welcome to RHLP Galactic Cabs Tours 9000. Today, we are going to be the first people to see the system PSR B1620-26. To your left, you will notice that there's no washrooms due to budget constraints. We had to put them outside. Good luck. And alright, so this flight will last about 10 minutes. And to go to our destination, obviously the solar system, take about 30 seconds. We'll be cruising at a speed 33,537,850,400,000 kilometers per second. Please fasten your seatbelts. Oh my god, the lava lamp. I'm so tired. I'm so... Oh my god. This is the worst thing ever. Welcome to PSR B1620-26C. This is the oldest known planet to exist. It's actually pretty impressive that it still exists. So it's a noble gas giant. It's completely toxic for reasons we'll explain later. It's about 0.4 times bigger than Earth's sun, and no one really knows what this planet's made of. But I mean, I'm obviously till today. So people theorize that it's made out of the same stuff that Jupiter or Saturn's made of, other gas giants. So most likely it's made out of hydrogen, which, by the way, is the fastest and lightest element on the periodic table. Who knew? Its weight is only 2 grams. Oh, it's also made out of helium. Whoopsies. Yeah, so it's pretty impressive that this planet is actually around today, because it's had a heck of a tough time. Let's take a closer look. So, the reason why this planet is so impressive is that scientists didn't think a planet could survive this kind of treatment. From the pulsar, that thing, the white dwarf, the everything. People thought it would be blasted apart by the gravity, by the other things. It actually ended up making a lot of discoveries and new theories. Most of them are too boring to feature here. Anyways, here's how the planet got here. Oh! You can see how the sun went supernova, the now white dwarf, went supernova, and powered up the neutron star, making it powerful enough to become a pulsar, which we'll explain later. And you can see how the poor, battered up old planet, that guy is orbiting around these two with all the gravity and all the everything. Well, all this happens. It takes 95 whole years to make one orbit around this sun, meaning that not only is it being battered by radiation, toxic blast, low atmosphere, being a gas giant, that doesn't help. It's also being blasted by the radiation from both its suns. What a lovely vacation spot. This planet. So yeah, this planet wasn't actually discovered by looking at it either. It was discovered by pulsar timing, which is where some weirdo in a big old tower looks through his thing and sees a little bit of a blip in the sky. And because of science and smart, he was able to discover that it's actually a planet and 2 stars. One was a pulsar, one was a white dwarf. I wouldn't be able to tell that. Look at this guy. Can you tell what that is? No, I can't. I don't know. Well, the story cut is quite short, but that little beam right there is a pulsar, and it's giving our ship a large amount of radiation that is very deadly. Whoopsie doopsie. That's actually what we'll be taking a look at next is the white dwarf. I'm so tired. Oh my god. Alright. Did you play the wrong video?
Nope.
Okay, so here we are at our second stop, the undermassive white dwarf. Well, actually, she's a systems white dwarf, but it is an undermassive type of white dwarf. It makes it 32% of the size of our sun, but also the same energy output. Dangerous. So, another interesting fact about this thing is that it's almost entirely made of electron-degenerate matter. So, what the heck is electron-degenerate matter? It sounds like... I don't know what. When a star goes supernova, right, its outer layers are blasted off into the middle of who knows where. And its inner layer starts shrinking real fast with a lot of gravity. That causes the stuff in the inside, all the atoms and the particles and things, to start squeezing down. And if it makes it from this guy, either healthy to where all the electrons electrons start circling other nucleuses, it makes some interesting, weird stuff happen. Now, with the white dwarf, sadly, it just doesn't have any interesting properties. It doesn't have any cool reactions or anything. It doesn't look like it's doing much right now because of that. In fact, they don't even emit light. What kind of bozo sun is this? No, it's actually just that. It's just heat left over from when it was a star. So it's pretty cool. The last interesting fact is that it's going to become a clump of diamonds. Scientists theorize that there's a little core in the inside there. I don't know, about the size of our school to Toronto, which sounds like a lot, but when you think about it, it's bigger than Earth. And it's got a Toronto-sized little thing in it. Anyways, that is full of the same material as diamonds, so that's pretty cool. When this thing dries up with its heat in about 20 billion years, the only thing left will be a little crust, which is, 3 diamonds, I guess. But, enough of that. You didn't come on this thing to see, the white dwarf. You see the pulsar and the planet. So let's go to the pulsar next. Hopefully we don't get cooked. Anyways, here's the PSR B1620-26A. PSR stands for pulsar. Alright, so here it is. As you see, we're keeping a careful distance because this is kind of deadly. Those little beams there are full of radiation, but I'll explain that in a second. So, this is actually a neutron star. A pulsar is a neutron star. So, a neutron star is when a big star goes supernovas, as I said earlier. Its layers are blasted off, yada yada yada. But depending on the size of the star, the force of this contraction will either, keep it steady, keep it stable, it'll be fine, or it'll get crunched. And crunched into this little tiny ball. You know how small it is? That small. That seems pretty big, but you could take a city bus around that. It's a star. The whole sun into an area that's like a block of this. So as you can probably tell, these things are powerful. So powerful they have the universe's strongest magnetic field. This again, with our little ship full of big little parts. Oh, that thing. Who knows what happens to the tinfoil? Anyways, yeah. So a neutron star usually isn't strong enough to make those beams up the side, as you can probably imagine. Now, you probably don't know what makes them. So when our other star from way earlier, the white dwarf, this guy right here, when he went supernova, he actually fed a bunch of outer layers into this thing, powering it up, making it magnetic field so strong they will start ripping out electrons from the inside of this core and blasting them up the side. At such a high speed, it also makes gamma radiation, which is why if you're standing in it, you will die a lot. So, poor planet, poor B1620-A is getting cooked over there, because that's his main light source. Yeah. So, summarize our trip. B1620-26 is a regularly unheard of star system with oldest planet in the universe, 2 different types of stars, the star is the same thing. Oh. Seems like I'm getting a transmission on the transmitter, the whatever. Oh my gosh, let's see what it is. What? Oh, that's it. A bunch of static. We're not near any radio stations. Probably one of those cool space phenomena. See, I'm putting it in the criteria. I'm so that it's just random bursts of static. Currently, scientists believe that it's just 2 planets going, and then a ton of stuff comes out. If electron beams you on the side of that star, who knows what happens when 2 of those collide? There's just those little blips of static. It's just a few seconds long, and yeah. I'm sorry if it's so terribly presented. It is currently 10:35, and I spent all night and all weekend and all day making this, and it is so suffering, and I'm dying, and everybody's dying. Good night.